Okay, this is Mr. Peterson. I'm finishing, I'm doing page 2 of the notes for Algebra 2, section 8.4. And this example 3, what we're supposed to do is consolidate these logarithms. So you can see there's two separate logarithms with a minus sign in between them. You make that one logarithm with a division in its place here. And then you might have to simplify, so I'm going to go log base 3 of 4, and there's my answer. 24 divided by 6 is 4. Okay, on this next one here, we're going to first of all take these two multiplications and we're going to make them powers. And that's the power rule in action. Log base 2 of x squared plus log base 2 of y cubed. And then the plus sign gets traded in when we consolidate for a multiplication, which is a product. So we're using the product rule now, and we're done with that problem. Okay, this one has an addition, which becomes a multiplication. So that's natural log of 30. And then this minus sign becomes a division. And when you take 30 divided by 2, you get 15. So this is the natural log of 15. Now, if you want to check this, you can type the original and the final answer, and they should agree with each other. You could do that on this problem also. A little more complicated here. You'd have to store a positive value for x and y, and that's kind of hard to do when you have both x and y. All right, log base b of 64 minus log base b of 8. 2 times that, so I'm going to first take that 2 and make it an exponent. That's the exponent rule. And I'll simplify that to 64. Now the quotient rule kicks in. You got a minus sign here, so you're going to take and divide these numbers, and that gives log base b of 64 over 64, which is 1. And then the following logic kicks in. What exponent, logarithms are exponents, would you put on this base of b to make it turn into a 1? And b to the 0 will equal 1. Now if you come up here, you'll see that answer quicker. Log base b of 64 minus log base b of 64 is just going to be 0. So if you shortcut this and just go straight across there, you'll see that that equals 0. Okay, on this next one here, we're going to take the power rule and make that an s squared. And then we're going to do the quotient rule. That minus sign between these two logarithms can be exchanged for a single logarithm with division replacing that. So there's your answer. Okay? This one's a little different, and the reason it's different is because the 2 actually distributes here. Which means that both of these are squared. And then we put it together with the quotient rule. So log base 7 of s squared over t squared. Now another way to think of this is like this. Log base 7 of s over t, both top and bottom squared. And if you want to write it that way, you could start right here by doing the quotient rule, s over t there, and then just putting your squared on it later. All right, so this next one here, we're supposed to go the other direction. We're supposed to expand this. So I see a product right there between the a and the b, and I see a power. And that second power only affects the b. So it's going to look like this. Log base 3 of a plus log base 3 of b squared, and now I'm going to bring this down in front there. So it's going to look like this: log base 3 of a plus 2 times the log base 3 of b. And there's your answer. Okay, this one has a 12 times x divided by y inside of it, so it's going to be log base n of 12. The times is going to put a plus there, log base n of x. And then the division turns into the minus log base n of y. Notice all three have logs on them. Okay, this one here, I'm just going to rewrite. The n to the negative 1 power is 1 over that, so it's going to look like this. 4m over n, and then this problem and the previous are almost identical types of problems. Log of 4 plus log of m minus log of n. Now you could treat this as a power, and that is a multiplication. So you'd have a plus sign where the multiplication is, but then the power would come down and make it negative anyways. So that's another way to think of that one. Okay, this one has a third power that affects both the 5 and the a because of the parentheses. So it's 3 natural log, let me try that again, 3 natural log of 5 plus, and the plus comes from the times, it's in the middle there, 3 natural log of a. The reason the 3 is on each of them is because this parentheses extends the influence of that third power to both parts of that base. Now down here, the third power only applies to the back half of it. So we're going to say common log of a. We hit a multiplication there, so I have to change it to plus. And now I'll go 3 common log of b. And you can see the 3 only applies to the back half, just like this third power only applies to the b part of the that's the base b. Here the difference is the 3 applies to both parts, so this is 3 log of a plus 3 log of b. And that used the product rule because of the multiplication right there, and the power rule applied to both parts of it. And that does it for page 2 of the notes for section 8.4.